I was watching in the back and trying to figure out which of the 5 chairs I was going to sit in while I talk to you, so I guess I'll figure that out as we go here. Well, good morning. This is our moon. It's hanging around all the time, and we don't usually pay a lot of attention to it, but a lot of people thought a lot about it a couple days ago when it happened to make a pass between the Earth and the sun, and we got to experience this cool eclipse event. Who's kind of a space solar eclipse nerd who watched it? Some hands. Anybody drive like hours or days to be able to go observe? Cool. Awesome. Well, like I said, we don't think about the moon a lot. That was kind of a rare occasion, but there's probably just one window in American history where people really thought about the moon more than they did at any other time in history. And that was in the early 1960s. Specifically, this speech was made in September 1962 by President John F. Kennedy. And you probably know the line that he said, which is, "We choose to go to the moon in this decade, not because it's easy, but because it's hard." There's a lot we could learn from that speech when we think about vision and leadership and rallying people around a cause. But the important thing for the purpose of our talk today is to realize that this speech actually was a catalyst for how the nation focused a lot of its technology innovation. And it was a centering on a particular goal that led to all sorts of developments that were needed to make this happen. And the good thing is that shortly thereafter, specifically in the summer of 1969, we had the first humans, first Americans, who made it to the moon. Took a ton of innovation, like I said, things like figuring out what is a lunar lander going to look like and how is that thing going to work, innovations in rockets, in capsules, in life support systems, spacesuits, on and on and on. There was a tremendous amount of innovation, and ultimately it all came together and enabled reaching a goal. And we know a lot of the names of the people who are part of this pursuit, particularly astronauts. Everybody knows Neil Armstrong. Everybody knows Buzz Aldrin, and on and on. But how many of you know who this person is? Anybody? Maybe nobody? So this is Margaret Hamilton. And Margaret was responsible for a really important piece of the Apollo mission, and that was the Apollo guidance computer. The Apollo guidance computer's job was to live inside of the space capsule and to do all of the directing of the capsule, all of the guidance system work, the intake of telemetry, driving the adjustments, and interacting with the astronauts. And it is actually one of the earliest versions, perhaps the earliest version to ever exist of edge compute, which is what we're going to spend a lot of time talking about today. So this is a picture from Wikipedia of the Apollo guidance computer. It existed at a time when computers were pretty big. They took up a lot of physical space, and they were really expensive. And this was a computer that was able to utilize integrated circuitry. It was one of the early examples of that. And it got to shrink it down instead of being something that potentially took up a whole room or a large portion of a room to something that took up 1 cubic foot of space, and it weighed in at about 70 pounds. So you can think about in an edge environment like a space capsule, we can't have 80% of it covered with a computer. We got to figure out how do we shrink things down into a constrained space and then still achieve literally the mission objectives of being able to operate successfully out in space with low latency and very high potential for disconnected communications back to the mothership, to the Earth in this case. And so what we're going to do this morning is spend some time talking about the history of edge computing through 3 distinct periods. What I call the early years, which we just started talking about, the modern era, and then we'll take a peek at the kind of future frontier. Where are things going? Now, the word edge can mean a lot of different things to different people, and so for the purposes of my talk this morning, I want to make sure we're all thinking about edge the same way and thinking about the same things. So we all know the cloud. There's a number of cloud providers as well as the data center world. And the way I think about edge is there's a spectrum. Off the slide on the right side is where our user would be. And there's a number of different type of edge solutions that exist as we move closer and closer to the user. Regional edges, things like telcos, even cloud providers providing CDNs, CDN services like Cloudflare that also allow compute at the edge via functions and things like that. That's one class of edge. The next one, we can call it near if you're thinking from the user's perspective, which is what I like to do, or you can call it far edge if you position yourself in the cloud. Doesn't really matter. This is the area we're going to focus on today as we look at the modern era, but this is a new class of edge compute that's emerged, not actually at the user yet, but very, very close, in very close proximity to where things are happening, whether it's with the user or in a business. And then finally, on the far end, we have the device edge, and there's more and more push to put things actually on the devices. There's lots of innovation in chips. There's lots of stuff that's happening there to make that more and more common, but that's another option as well. We're going to focus specifically on what I call the near edge. Before we go too far, I want to give you just a peek into the way that I think about this spectrum. And maybe this is a bit of advice too. So the way I think about it is ultimately, there's a lot of places you can run a workload. You got to pick one. And some of them are optimal and some of them are suboptimal. And when I think about how to do this, I think of this phrase. You want to run your workload as close to the user as necessary. So in order to create the great experience that you want, the low latency needs that you have, the reliability you need, but no closer. So we don't want to put things on the edge just because we can, but we want to put them there when it creates the experience for the user. This is all about the users and the experiences that people have of our businesses, and no closer than that. All right, so let's jump back into our history lesson again in the early days, and we just started our intro talking about the Apollo mission set and the success that happened there. Just reminding you again, the initiator for Edge in that environment was literally mission critical workloads that needed to run in disconnected states with really low latency and exist in a physically constrained space. So our second example comes from my world. I work at Chick-fil-A as the chief architect, and we've had, as long as I've been there, Windows servers in the back of our restaurants that run our point of sale or POS system. And every retailer that I know of has something similar to this, whether they're big box retail, they're restaurants, whatever else it may be, but they've got some sort of solution in most cases where there is some sort of server in the back that is either absolutely critical to the operations of the facility. I'm going to probably say restaurant a lot because that's my world, but absolutely critical to the operations of that, or at least somewhat important. I know in our business, we don't necessarily depend on the POS server to be available to take customer transactions, except in the drive-through where we have a solution where we have iPads out there and we're moving the queue back. So it's very critical to us in that regard. And again, driven by a lot of the same things that we saw with Apollo, the desire to have something that drives a system that is available as the LAN and doesn't really depend on your network connection out, and that where we can run things that we need to run a system. So you may be thinking, sounds kind of modernish, why is it in the early days? Well, the key thing that I observed about a lot of these solutions is that they are really single purpose in mind. They're proprietary solutions usually, and they think of this server as theirs. That means it's really difficult to put other things on this type of solution. You want to integrate with it. You want to deploy some other kind of application that lives alongside that's going to help your business. These environments are really not friendly to that. And in my experience, we often had to try things out, go through huge amounts of testing, put a ton of effort in, only to find that we ended up with some sort of instability. The new thing got blamed, it got rolled back, and we ended up not being able to pursue that particular objective. So that's number two in the early days, the POS server. And then third is the PLC, or programmable logic controller. Again, you're going to notice a theme here. This is common in manufacturing, and it's really all about driving the automation that happens in a factory, changing variable speed motors and collecting telemetry data and making sure that the automation of the product that's being produced happens successfully. And these things don't tolerate much downtime at all. But again, they are very restricted in what they run. They're really good at doing one thing. They're not something that you can take another application and deploy it into, and they're not something that is really easy to integrate with. I've tried to do it to help a nonprofit before, and it just didn't work. It's really, really challenging. So that's a little bit of the history of our early days of edge compute. And just to recap, we saw there was a necessity to have local processing. Think about the Apollo mission, think about restaurants with point of sale systems, think about PLCs in factories. Again, we talked about latency challenges and perhaps bandwidth limitations as well. Not being able to get all the data out that we need, needing to be able to run if we're in a disconnected state, being the next one, when we have a mission critical application. And then finally, we saw that a lot of these solutions were really single purpose. Like they saw themselves as the only thing that existed in the world. They were the only app, they were the one app, and they used what was available to them, and they weren't really friendly to any other objectives that could potentially exist. All right, so let's shift forward here to the modern era, and just to mention briefly, the early days, I just say would start around 1960 when we talked about the Apollo mission, but they haven't really ended. So these solutions we talked about, other than Apollo's computer, these are still very common in the industry, and they probably will be for a long time. So the modern era isn't really about time necessarily as much as it is a change in paradigm and a change in the way that Edge works and can empower businesses, and that's what we're going to look at here in the modern era. I think the modern era is characterized by two big shifts. One is platform thinking, and two is congruence with what is often called the cloud native paradigm. That's a buzzword. I like to define buzzwords if we're going to use them. So when I think about what a cloud-native paradigm is or what a cloud-native workload looks like, it would be these things that you see up here on the screen. Things like microservices architectures, operating your systems with DevOps practices, horizontal scale, offloading the heavy lifting that comes with managing infrastructure to somebody else who's a partner, all these types of things. So these are things that would be characteristics of those types of workloads. And if you think back to our first slide with the user at the right and their devices and the cloud on the left, this is my thesis, is that as you move away from the cloud and towards the device where the user is, along that spectrum, you're going to get a decreasing similarity to the cloud paradigm. But what we just said, we want to maximize as much of it as we possibly can along the way. Things like at the near edge, we're just not going to always get unlimited horizontal scale. There's going to be some capacity constraint there based on our physical space and the devices that we can afford to deploy and things like that. And then at the device, we may have very minimal familiarity with that cloud paradigm. So to talk about the modern era, I'll talk about what I know best in this arena, and that is a little bit of a case study on Chick-fil-A. I'm the chief architect at Chick-fil-A, and we've been doing edge computing solutions at scale in our restaurants since about 2017. So we've got roughly 7 years of production experience going on with this particular stack. So why would a company like Chick-fil-A do something like this? And the reason is, if you've been to Chick-fil-A before, you probably have noticed that we're pretty busy. We have a lot of cars wrapped around our drive-thru. We have a lot of team members scrambling about serving guests. And to us, it's really important that in everything we do, we have a really positive experience on all who come in contact with Chick-fil-A. That means you as a customer. That means our employees who work there, our owner-operators that run the locations. And so we see technology as a really important way to help make sure that all of the people who come in contact with us have a great experience. You get hot, fresh food. Team members have a great job that isn't extremely taxing and is enjoyable to work in. Operators get a great business opportunity, et cetera. And so our edge computing solution really started out of a need to start to make our restaurant fabric more intelligent, which led us into IoT, and IoT led us into the world of edge compute. We wanted a lot of the things that we talked about at the start in the Apollo mission this morning. We wanted to be able to run things that were important to the business if we were offline, if we had poor internet connections, and we wanted to be able to have applications that lived in an environment that wasn't single purpose. They could talk to each other, they could talk to things in the restaurant, they could orchestrate interactions, provide information to team members, and even, we haven't quite got there, but even automate things potentially in the future. So organizationally, this is where I would say think platform comes in. This is what I call our organizational topology, and the things in red are the things that you've got to account for if you're going to build a platform that's going to live at the edge, probably things that you just heard a lot about in the previous talks this morning. You got to deal with the compute part, you got to deal with the operating system and how you set all this stuff up and how you're going to operate all of it going forward, patch it, all those kinds of things. You got to deal with like orchestration layers. We're container driven in our world. We had the benefit of being greenfield at the edge, so we only do containers, but regardless, you got to be figuring out, all those things as well. And then you've got a layer of the 4 boxes at the top, which are what I would call primitive services, kind of stealing that from Amazon, and Andy Jassy had a great write-up about that in his letter to shareholders that I would recommend. But primitive services that developers can use without having to reinvent the entire stack for every solution that they bring. So how do they message other applications inside of the restaurant? How do they get deployments? How do they do authentication and authorization operations? What if they need a database? So the platform team is taking care of those things in our environment, but they don't build all the applications that run at the edge. They don't build things that talk to the point of sale. They don't build smart kitchen interactions, and they don't own the IoT devices that connect. So we have an approach, which is a platform that lets all those different teams be able to build and deploy applications on top of this stack using these primitives, but also bring their own opinions to the table when it comes to programming languages or monitoring and observability tools or the different things that they need to do to operate their application the way that they need to and want to. So here's a peek at what the architecture looks like. I like to start in the bottom corner and just talk about IoT again. It's the things that drove us to connect. It's also the screens and interfaces that the team members use in our different restaurants. Obviously, we got to have connectivity. We're very Wi-Fi driven in Chick-fil-A restaurants. That's been our go-to, and that's worked great. Then we've got the edge stack. You just saw sort of a little bit of a picture of it, but this is more the service view of what's running there. And for us, we stood up Kubernetes in the form of K3s to manage that orchestration of workloads. which really, at the end of the day, just means for us, we got 3 hardware devices, and if my application is breaking on one of them because that node is dying or has a problem or drops out of a cluster, I want to make sure it starts somewhere else. Like, this isn't over-engineering. This is just making sure that we have reliable workload placement and execution across a cluster, across the scale of 3,000 unique restaurant deployment footprints. And then, of course, we can't just pretend the edge is the only thing that exists. There's a lot of work that needs to happen and a lot of operating this architecture that is driven out of the cloud. So all of the data collection, all of the telemetry collection, all of the dashboarding and operational support work, all of the workload deployment, all that stuff lives in the cloud in AWS. We've solved for a number of the things that you guys have heard about, zero-touch provisioning, so that we don't need humans there to deploy our architecture. All that stuff lives in the cloud control plane, and so you've got to have that and need that as well. All right, so what would we want this architecture for? This is a use case that'll hopefully help you maybe make everything tangible that I just talked about. This is a mix of current real world and a little bit aspirational. So I sort of tweaked it a little for the presentation, but I think you'll get the idea. So let's start with a team member whose job it is to drop different chicken products at different times. We have nuggets, we have fillets, we have grilled sandwiches. I'm gonna make y'all hungry before lunch. We've got a bunch of different options. So if you picture a team member who is trying to figure out how to make sense out of all the chaos that you see as a customer in the restaurant and figure out, like, what should I do right now? Like, there's not a fryer for everything. I gotta make a decision and I gotta decide how much. And if I don't do enough, people are yelling at me because they're waiting and the lines are long and customers are unhappy. And if I do too much, I end up with food waste. So I'm trying to strike the balance between those two things. So pretty easy to imagine, well, hey, Chick-fil-A is a big company. Can't you just look across your sales transactions over time, create some kind of forecast down to the 5-minute level, maybe the minute level even, and just use that? And we've done that, and that sounds awesome and works okay. But the reality is that things aren't consistent day in and day out at any business. They change all the time. There may be a wreck in our world that happens on the main street, and so there's a lot less people coming, or there may be the proverbial school bus that pulls into the parking lot, and 80 kids get out coming from their football game, and we're way more busy than we expected. So if we're ever gonna inform team members exactly what they need to do in a more accurate way, or if we ever wanna automate anything in the future, we'll need more data to inform our decisions than just this high-level forecast. And so that's what this architecture exists to do. So imagine a containerized application built in the language of your preference, and it talks to this cloud sales forecast API that's built out from all this great data that we have across all these stores and looks at the specific store and the season and all these different factors. It's a great machine learning model, and it gives a really good answer back to that application. That application can hold on to that, though, and then it can take all these other things that we have from our IoT ecosystem. Like, what are the fryers doing and how much work is in progress and what products are in progress right now? What about camera vision or LiDAR data, looking at the traffic that we're experiencing in our drive-through, coming onto the property, people in parking spaces, people queued up inside waiting to order? And then, of course, the actual point of sale data, like what has been rung in? What's like the imminent demand that we know we have right now? And then mash that together to ultimately say, hey, Joe, who was working on chicken, he was gonna drop 9 fillets for making Chick-fil-A sandwiches, but right now, actually, the more optimal number would be to do 12 because of all these factors that we brought together and considered. So this is just an example, something that we've worked on, and parts of it are in production in the real world and parts are in progress, but just kind of gives you a flavor of why would you need to have an edge architecture and how could it help impact potentially your business. And we're not changing. There we go. Awesome. Okay, and so to end the modern era, a couple Gartner slides. You could probably find the industry that you represent here somewhere, and then it's interesting just to look across and see, like, what are different industries maximizing edge for? I told you a lot about retail. It's what I know really well, but there's a lot of different use cases across all these different industries, and they just seem to be growing rapidly. So let me recap what we talked about. Talked about the modern era being driven by IoT and automation. I see that across many examples. It's true of us, but true of others. Deployments in the past that we talked about were out of necessity, but it's actually become easier since we have more platform thinking, one of our next points, to deploy out of user experience as well, making great user experiences. Low latency, fast, enjoyable. Maybe you're in gaming. You can make your game run really fast for people so they're not waiting and buffering and all these kinds of things. So that's a great opportunity in the modern era as well. We maximize our alignment with a cloud-native paradigm. We talked about platform thinking in terms of the way that we work. And we didn't really talk about it, but I wanted to highlight that we're container-driven, but most people aren't going to be greenfield. They're probably going to have a heterogeneous pool of workloads. They're going to have containers maybe, or they might be moving that direction. But VMs, WASM is one that's emerging. There's other types of workloads. But the great thing is that a lot of the solutions that exist out there and sort of the principles of the modern era are that we can support heterogeneous workloads all together and all actually interacting with each other, enabling things to happen in the business, which is super cool. And then one more from Gartner, just to say, I think we're just getting started in the modern era. Less than half of people feel like they know that they want to do something with the edge, and perhaps that's lack of information, ignorance about opportunity, their business hasn't gotten there yet, or they're too small, or whatever. But we've got about half people who have deployed or who are looking to deploy in the next couple of years. So I think the modern era is going to be characterized by a move, and maybe tacked off with a move towards a lot more people using edge to support and enable their business. So while we're still in the modern era, before we go to the future, for those who are maybe just getting started, just wanted to recap a couple lessons learned from my experience at Chick-fil-A and maybe highlight what you'll need and give you just a little bit of advice, a couple quick points of advice from observing what we did over a 7-year time period. So what you need first is you need this should look familiar, similar to the pictures before, just genericized a bit. You need all the stuff in red, and then you got to figure out how to interact with all the stuff in orange. You got to figure out what's your platform going to look like. How are you going to make all these things happen? How are you going to do zero-touch provisioning if you need it, which you probably do? Thousands of copies of Edge is common, and that's a lot to manage, a lot to stand up. So you got to find a solution for that. How are you going to orchestrate and manage all of these workloads, both your primitive platform services and your applications? And how's all this stuff going to interact across the ecosystem of IoT devices, the humans who are involved in the different parts of the process, the operational support model, and all of those things. So this is what you need to figure out. It's a lot, and that's my first point here in my advice is Edge is really cool, but it's difficult. And I would recommend deploying out of necessity and business opportunity, not because you can. I think most people might default to that, but if you're going to do it, you need a really good reason to do it. It's not easy. Number two, I think, is to be honest with yourself about what constraints you face. Those can be budget, knowledge about how to do these things, resources to work on it, humans available at the site to deal with things that go wrong, network constraints, big one for us, good solid network, but minimal programmability, which makes it really hard to dynamically onboard things. So think really hard about what constraints exist in your environment, in your site that you're thinking about putting Edge, and then really focus on how you can look at the tools that exist in the marketplace, layer in the things that make sense in order to manage those constraints, but do it really intentionally and actively. We talked about the principles of the modern era and specifically the cloud native. I think those are great things to aspire to, but also don't get hung up on model purity. Like if you can't get to containers, don't not do Edge. There's lots of positives that can still be gained from that. If you're not going to get pure horizontal autoscale because you're going to pick a number of devices and that's what you're going to have. Probably for at least a couple planning cycles in your business. So you can't have infinite scale, so you got to be okay with that. But you could have scale, horizontally of pods and Kubernetes, for example, and have that at least work, and then manage your workloads accordingly to deprioritize things that are less important and prioritize the more important. Think platform. We already talked about that quite a bit. Don't overlook the operations side of it. It's a lot of footprints, and it's really easy when everything is great, and it's really hard if something goes wrong. So how are you going to make that work? How are you going to find the right partners that can operate your environment and make sure that it's able to really achieve those things we talked about? This is about resilience and availability and great user experiences. When it breaks, that hurts. It's there because it's supposed to be better and more available than what the cloud or your data center is giving you for a particular use case. So don't overlook that. And then I like to say, instead of build versus buy, create, consume, compose. But create is similar to build. And consume is similar to buy, and compose is really about, can you take a bunch of pieces that exist out there, custom software and hardware work, commercial opportunities, vendors, platforms, and open source, things like that, and build your solution out of those. So I think being intentional about this and really seeing how far can you get with stuff that's already there, and then do just enough to get it to work for your business would be my advice. All right, and now we go into the future. We talked about the early days, talked about the business critical workloads, low latency, disconnected states, constrained physical space. We talked about the modern era that still has those same problems, but seeks to address it with a cloud native paradigm and a platform mindset. So what is going to change in the future? And the first thing I think we already heard this morning, it's going to be the age of AI. If you don't recognize this image, it's from the movie iRobot with, is it iRobot? Yeah, with Will Smith. Hopefully I got the name right. But good movie. There's an AI in it, and this is her. A little creepy, I guess, if it's on a big screen right in front of you. But AI is going to be one of the big things that emerges, and it could look many different ways, but could be co-pilots for your employees, or voice-related experiences where you're using generative AI models behind the scene, or any number of things. We could have a whole talk about just how machine learning and AI is going to change the world or whatever. But the reality is, it's going to probably keep starting in the cloud, but it's going to quickly make its shift to the edge, and it's for the very same reasons we've talked about. People want to depend on it more than they can depend on the availability of their network connection. They want to be sure that it's going to work to create the experience or the automation or whatever that they need. And so I think the age of AI is coming, and we're going to see more of it. The second characteristic is, I call it the data explosion. There's going to be so many things, not just IoT, but also camera vision use cases, LiDAR-related data, all kinds of things that are collecting data, in the places where work happens or the places where our users are, even from their devices and things like that. That's going to be necessary. And as that happens, and we want to give them immersive experiences, really low latency experiences, it's just going to be absolutely necessary that that stuff lives in a lot of cases close to the edge, because it's just too much data to be pumping out to the cloud. Sending video to the cloud from 20 or 30 cameras is pretty much a non-starter for most people. So if you can't go to the cloud, what are you going to do? You're going to have to find an edge solution. And this is going to push, obviously, like GPU and other types of chips, becoming more, I think, eventually cost-effective. We're probably not there yet. More cost-effective, smaller, more edge-friendly. And I think that's one of the big things that we're going to see on the frontier. And I wish they were all fun, but there's also another thing that happens, which is government gets involved. And we already see a lot of government involvement in data, technology, privacy in a lot of places, especially Europe, some states in the US, California stands out in particular. So we've got a lot of government that's mandating things, trying to take stances on privacy. And in a lot of cases, that's going to force computing to happen in particular jurisdictions. You're not going to be able to move that data somewhere else where you maybe would like to. It may be the optimal place may be the cloud, but you may not be allowed to put it there anymore. You may have to do things closer to the user. I think this will be yet another reason that we see a huge adoption in edge and a new class of use case that has to get tackled there as a result. So just to recap, that's a bit of the history of edge. We had the early days, the modern era, and then these new frontiers that we're seeing with AI, government regulation and compliance needs, and the explosion of data via IoT, computer vision, and other types of sensors. So maybe a final question that I rhetorically ask myself would be, how can edge transform your business? So I think the answer is, if you have any of these things that we've talked about, if you have an application that needs to run with really low latency because that matters to your user, then you might need edge compute in your environment. If you want to bring together a whole bunch of things within the ecosystem of your retail location, your restaurant, your manufacturing facility, your oil field, whatever it may be, you want to bring those things together, collect that data, and make local decisions that drive behavior from humans or maybe robotics in the future. You may need edge computing in your business. And we could go on and on about the opportunities. So in parting, just want to remind you that when you think about doing that, if you need edge in your business and if you pursue it, just remember, run that workload as close to your user as necessary, but no closer. This is where you can find me, and I'll be around the rest of the week. Thank you, guys.